Okay, guys, this is the word problems for exponential functions or exponential functions applications. So the last part of this unit, for some reason, the scan came in a little grainy. Anyway, you have the same note, so I'm going to go over the actual note that we did in class today. So here we're going to write the equation. You have a bunch of computers called hosts, measure the growth of the internet. In 94, there are 3.5 million hosts. Since then, the number has been growing at 84% annually. This reminds me of the Disco Stew episode of The Simpsons, where they had the sales of disco albums in 1970, and they were here, and then 1971 they were here, and 73 they were two, 73 they were here, and the projection was by the year 2000 they would be like $1 gazillion would be made through disco sales, disco record sales. So sometimes things continue, sometimes they don't. This is an older question. 1994, 3.5 million hosts. Will it grow at 84%? Oh, we'll just go with the question. Write an equation that expresses the number of hosts over time. So we're going to use in millions, and it says in millions here. And that's H. That's an H. So it's all based on a, b to the x. A is your initial value, b is what you're growing by or multiplying by, and x is your exponent. So in this case, we're going to have h at n. So h is the number of things, hosts, over time is equal to something. And you get your initial amount, which is 3.5 million. So that's from up here, and it's growing at 84%. 84% is 0.84 as a decimal. Whenever you're going to be looking at a percent as what's being multiplied, as opposed to doubling or tripling or something like that, what you'll do is you'll add that if it's growth to 1. Okay, so you have 184%. 1 represents the initial amount, and you add to it 84.84, so you end up with 1.84 to the power of n. Estimate the year that we get to 100 million. So this is the whole logs part of the course. So again, with logs, the way it works is this. A real quick thing with logs here. If I have let's do this. 2 to the x is 8. 2 times something times something. 2 times itself times itself times itself. A certain amount of times will get you 8. How many times is that? Well, to find that, once again, what you do is you take the log of each side. So you take the log of 2 is equal to log of 8, and then you bring down the x here. So what happens is this comes down, log goes here, log goes here. We talked about that in class, and I think it's in the last video. And then to solve, log 2 is a number, log 8 is a number. To solve, you go log 8 divided by log 2. Put that in your calculator. Hit equals, please hit equals, and then you get 3 in this case. And that will tell you that 2 to the 3 is equal to 8. Okay, so let's go back to this question here. To find n, you want to figure out when do we get to 100 million. So we set this to 100 million, or 100, because it's already a million, is equal to 3.5. 1.84 to the n. Step 1 is to get rid of this 3.5. It is, so I want to get n, so it is multiplying here, so it's going to divide on this side. So the first step is to divide each side by 3.5, and when you do that, 100 divided by 3.5 is 28.57, and then that is now equal to 1.84 to the n. You take the log of each side, so you end up with this, n log 1.84 over log 28.57. And then over here, I'll just keep going. N is equal to, or I guess I should write it like this, log 28.57 divided by log 1.84 is equal to n. Throw that in the calculator, and you get n is equal to 5.5. So 5.5 years from now, the base year was 1994, so you get to the year 1999 as your answer. Okay, so let's keep going. I'm kind of rushing here, but if I have glass stacked together, I lose 5% each time it goes through a pane of glass. That means I saved 95%. So 5% is gone. 1 subtract 0.05 tells me that 95% remains. If I want to figure out what percent is left after 8 panes of glass, all I'm going to do here is sub in an 8 here. So you're going to do that and sub that in and get 66%. Okay, and how much to get to 40%? Well, you set it up this way. 40 is equal to 100 times 0.95 to the, what was that, n, I guess? Can't see anymore. N, I think. Yep, and then what you do is then you divide each side by 100, so you're going to get 0.4 So this, bring this over, divide, is equal to this, to the n, and then take the log of each side. So I'm out of room here, so I'll go 0.4 log of 0.4 is equal to n times the log of 0.95, and n is equal to the log of 0.4 over the log of 0.95. Throw that in a calculator, and you get about 18. 18 is your answer. Let's keep going to 3. Canada's population is 29.6 million, and it grows at 1.24 per year. Estimate the doubling time for Canada's population. So that whenever you talk about doubling, okay, sometimes we have doubling time questions, but just this question sounds harder than it is. If we're at 29.6 million now, double of that is going to be times 2 is 59.2. Okay, so when you 29.6 times 2 is 59.2. So all you want to find out is when is the population here. Okay, well, we have to come up with an equation. So the population, the equation at a certain time is going to be ax plus b, the original amount, 29.6, times 1 point, and now this, you got to be careful here. This as a decimal, it's 1.24%. So move this over once, twice, or divide by 100. That's 0.0124. Okay, so 1.24% as a decimal. I know there's a decimal here anyway, but as a what we call a decimal, as opposed to percent, is moved over twice or divided by 100, and you end up with this. So that is 0.0124 is 1.24% to the n. And then what you're going to just do is set this equal and do what we did last time and move things over and play around with it. And this actually turns out to be 2 on the left, which you could have set it up like that, but it doesn't matter. Like this, take the log of each side. So I'm going to have log, eventually I'm going to have log 2 divided by this log 1.0124 is equal to n. And then you throw that in a calculator and you get 56 years from now, 56.24 or so. So here's a different question, slightly different, half-life. So we touched on this earlier on in the unit, but now we'll look at it a little more in depth. I'm going to switch over here. It's a little smaller. Let's switch up the color to blue. Polonium, 210, one of my favorite elements. Has a half-life of 20 weeks. So we talked about that in the past. What that means is in 20 weeks you're half as big. So when you have a half-life equation, what you're multiplying by is a half. You can write that as a decimal or a fraction. But so what's happening is you're told, instead of being told what you grow by or divide by or lose each year. So when we had a question like above where you lose 5% per plane of glass, so for each plane of glass you lose 5%, then you're going to multiply by 0.95 and then just have your basic exponent of n. Here, it's a little different. We're told we're going to get to half as big, to 0.5 as big, in 20 weeks. Okay, so it's a little different. The setup's a little different here. So when you have a half-life question, your base is 0.5, and then your exponent is going to be n, or t in this case, sorry, whatever your variable is, it's t, divided by your half-life, so 20 weeks. So t divided by 20, that's horrible, but t divided by 20 is your exponent. Always your exponent divided by your half-life. So t divided by 20. What's my initial amount? So it's still ab to the x. My initial amount is 25. So 25 times 0.5 t to the 20. And think about this. If t is 20, if I sub in 20 in here, if I sub in 20 as my t, so in 20 weeks, 20 divided by 20 is 1, and then now I'm going to take 25 and multiply it by 0.5. If I had 40, for example, 40 is 2 half-lives, which means I go from full amount to half to a quarter. Well, 40 divided by 2 is 2. 0.5 to the power of 2, or 1/2 to the power of 2, is equal to 1/4. So that makes sense also. Okay, so then I end up with a quarter of my initial amount. But you don't need a whole amount. You don't have to go by the weeks here. It doesn't have to be 20 weeks and 40 weeks. We can do it anything like this. We can put 30 weeks in. So all you do here is you set up your equation, then you multiply it by 0.5, 30 divided by 20. Now you can figure out what this is ahead of time, or on your calculator you can put 25, and then you're going to hit the times button, 0.5, exponent button, whatever your exponent button is. And then for your exponent, you can actually put bracket 30 divided by 20, and then hit equals. Now that's, I mean, you can tell me that 30 divided by 20 is 1/2, but sometimes I might ask you this, like 33 divided by 20. And in that case, just put this straight in like this and then figure out what you get. and you get 8.84. And you go ahead and try this on your own. Here, sub in 52, figure out how to get it on your calculator. So 25 times 0.05, 52 to the power of 52 divided by 20, and you end up with about 4.1 grams or 4.12 grams. Okay, so that's that. Let's keep going. I know this is long, but we're going to whip through this. I get 15 minutes before this thing turns off. Oh, great. What can I do with this now? Can I turn this upside down? Should I pause this? Should I pause it? That doesn't turn. Does this turn? Whoa, I saw something that might turn. So that's scanned upside down. Let's go. Let's go with this. Sound effects. I should probably pause this while I'm doing this. Ta-da. How long until 1 milligram remains? That's no. What's going on here? What happened? I'm gonna call timeout. Milligram. Anyway, let me fix that up later. We are going to do the one last question here. We'll do another half-life question, number 6 from your note. So this is talking about half-life of sodium 24 is 14.9 hours. And you start off with 40 grams. So A, B to the X again. And you want to have something set up, an equation where A and T are your variables. A is the amount after a certain amount of time. So let's set this up. I have 40 milligrams, so that's what I start off with. It's a half-life question, so my power is 0.5, and then my exponent is T over my half-life, in this case is 14.9 hours. So when we go through this question now, if you want to figure out how much is left in 48 hours, that's just A at 48. So you go 40 times 0.5, and then you go 48 divided by 14.9, and then you'll put that into your calculator, and you get 4.3. That's it. How long until 1 gram remains? You're going to set this like this, and then you're going to play around with logs. And this is going to be a little bit different. So that's 0.5 to the T 14.9. So then you divide by 40, divide each side by 40, and you get 0.025 is equal to 0.5. And the exponent was T 14 over 14.9. Okay, so it's this equation here. I just kind of made a mess of it. And now I want to solve for T. I still do the same thing I did before. I take the log of each side. So that will be T over 14.9 log 0.5. So this is a little different, but we'll deal with it. Over, and then this side is 0.25 log. And then next step, let me scroll down. My next step is the same as before. I go log 0.025 divided by log 0.5. So I'm bringing this guy over on this side. And now on this side, I have T over 14.9. You might be able to figure out what's going on here. Then you put this in a calculator and you hit equals. Don't forget to hit equals. And you end up with something. Or, sorry, another thing you do is before you put it in the calculator, you can just take this and multiply. The 14.9 is over here on the bottom. You bring it over here on the top. Or you can go 0.25 log divided by 0.5 log times 14.9. At some point, you're going to have to hit times 14.9. Bring that guy over, and you end up with a time of 79.3 hours. Okay, so that goes over here. You can do it like that. Is equal to T. Okay, hope that made sense. A little bit of a mess there, and some obviously some problems with scanning, but good luck. See you later.